Hello students, welcome back to this YouTube channel. In the previous lecture, we learned about heap, about building max heap, and today we will see how you can construct a min heap. In the same, there's not there's not a huge difference between the two topics. In the way it is the same procedure in which you build a max heap, you can construct a min heap. The difference, okay, first let's just take a little bit of revision from the previous lecture. What is a heap? A heap, as I already told you, a heap is a complete binary tree, and the binary tree is a tree in which the node can have at most the 2 children. A complete binary tree is a binary tree in which all the levels except the last level, that is leaf node, should be completely filled and all the nodes should be left justified. Okay. Now, what is heap sort? I already told you that what is a heap? A heap is a complete binary tree. And what is a complete binary tree? A complete binary tree is a kind of tree. See, this is my root node. This is the left child. And this is the right child. Okay. Now, if this tree has another child like this, and this right child is like this, let me put it, erase this one. See, now is this a complete binary tree? No, it's not a complete binary tree. It will be a complete binary tree when all its levels are completed. See, now we can say that if this is a complete binary tree because all its levels are complete. Now, what was heap? What is heap sort? A heap sort is a popular and efficient sorting algorithm. The concept of heap sort is to eliminate the elements one by one from the heap part of the list and then insert them into the sorted part of the list. Heap sort is the in-place sorting algorithm. Now, let's see the algorithm of heap sort. Now, you must know that there are some algorithms which are called in place. Why are they called in place sorting algorithms? What do you understand by the by this term in place sorting algorithm? See, in some sorting algorithms, there is efficient management of space or storage. The sorting is completed within the same storage, no additional space is required. Those kind of algorithms are termed as in-place sorting algorithms. Now, whenever you are asked to suggest an example of in-place sorting algorithm, you will say that heap sort is a in-place sorting algorithm. Now, let's discuss heap sort. Now, what happens in a heap sort algorithm? This is our algorithm. In a heap sort algorithm, you just apply heap sort. First, you build max heap. What you are going to do, you will build a max heap, and then we will start for I equals to length of array up to 2. Swap array 1 first the element present at index 1 with element at index I. Now, heap size of array should be equal to heap size of array modulus 1. Max heap. Now apply max heapify on these elements. Now, this is the algorithm for max heapify. Now, first let's learn about build max heap. I already told you how to build a max heap. Okay. So, let me explain you via an example. Since I already told you that how can you build a max heap, today I am going to teach you how you can build a min heap. Suppose you are given these elements 3, 10, 13, 98, 14. In the previous lecture, I told you how you can build a max heap. Now, we will see how you can build a min heap. The first step will be to insert the root element, the first node as root element. See, suppose I have inserted 3 here. Now, I will insert the left child, next element as the left child. Why is it inserted as a left child? Because it is a complete binary tree, and a complete binary tree is left aligned. First we will complete all the levels, then we will proceed to the next level. So where will 10 be inserted? It will be inserted here. Okay. In the next part, we will insert 13 as the right child of this tree. Right? Now what are we going to do? We will insert 98 as the left child of. Okay, one thing we forgot to do in this part while building this min heap is what? Let me erase this one, then let's come back here. Okay, now this was our root element 3. After inserting 10, what you will do? You will cross check it with its parent element. If it is greater than the parent element, parent node or not, because it is a min heap. So what are the properties of a min heap? In a min heap, the parent node is always smaller than the child node. So now is 3 smaller than 10 or not? It is smaller than 10. It's correct. So it is in min heap. Now we will insert 13 here. Where we will insert 13? We will insert 13 here. Check again, is it in min heap or not? Since 13 is greater than 3 and 3 is the root node. Root node is the smallest value element of this binary tree. So this is already in min heap form. Now you will insert 98. Where you will insert 98? 98 you will insert as a left child of 10. Right? Now, or what you will do once again, you will check is the parent of 98 smaller than the child node or not. It is already in min, it is smaller than the child node, so it is in min heap form, right? Now let me take a different example. Since all of the elements are already in a smaller form, in a like these are already kind of sorted. So let's make this 14 4. Now what you will do? Where you will insert 4? You will insert 4 as the right child of 10. Now check again, is it in min heap form or not? How you will check? You will compare the inserted node with its parent node. Is 4 smaller than 10 or not? Greater than 10 or not? No, it's not. Now since 10 is the parent node of 4 and it is greater than 4, so what we will do? We will swap its values. Okay, and now we will convert it into min heap form, right? So how we will do it? We will do it by swapping these values. Now where will 4 come? 4 will come here and 10 will come here. Now check the rest of the binary tree. Is it in min heap form or not? Since 3 is the smallest element of this binary tree and it is the root node. So we can say that this tree is in min heap form right now. Now this is how you do insertion in a binary tree, or I'm sorry, in a heap tree. Now let me teach you how you will proceed with deletion in this heap tree. Okay, one thing I already taught you in previous lecture, how we represent these elements in array form. Let's do that right now, and then we will continue with deletion. Okay, so let me arrange these elements in an array form for you to understand, so that we can then proceed with deletion. Okay, now this is our array. How many elements are there? 1, 2, 3, 4, 5. 5 elements are there. Okay, these are the elements after insertion. Okay, if we are doing indexing from 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Since this is my parent node, this was inserted first. Now, how will you calculate its left child? I already told you in previous lecture that its left child will be at which position? 2 into I position, which is 2 here. So, 4 is its left child. And which will be its right child? Its right child will be at 2 into I plus 1 position. Okay. Now, 13 is its right child. Now, similarly, the next node, since the next node, if the next node is 4, now our value of I is 2. Now, what will be the left child of 4? The left child of 4 will be 2 into 2. Okay. Left child of 4 will be 2 into I, which is 2 into 2, 4. So, this will be left child of this value, and its right child will be similarly 2 into I plus 1. Okay. Left child of right child will be 2 into I plus 1, 2, 3, 4, 5. So, 2 into I is 2 into 2, 4 plus 1, 5. This will be its right child. I hope that's clear. Now, what I want to teach you right now is how to do deletion in a heap elements. When the elements are arranged in a heap, either build max heap or min heap, then you will do the deletion. Only then how you will learn how to do heap sort. Okay. So, these are the elements I have arranged them in the array form. Suppose if you want to proceed with deletion in this min heap. See, in a heap the elements are always deleted from the root node. So, what we will do? We will delete 3. Suppose I am deleting it 3 here. What will I do? I will replace it with the leaf node of this heap tree. So, ten will be inserted here and 3 will be inserted here. Now, consider this node as deleted. Okay, I hope I am clear. You no longer have 5 nodes in this heap tree, you have only 4 nodes. Now, the same operation, how can we perform the same operation in this using this array? Since this was my parent node, what will I do? I will swap the last node. This is what I am going to do right now. I will swap this first node with the leaf node. This is what we just did in the heap tree, and this is the same thing we are going to do in the array form. So, what will be the first element now of this array? It will be 10 and this will be 3. This is what we just did. Now, this is the first step when we are doing deletion using tree, and this is the first step when we are doing deletion using an array. Now, the next step is, what will we do in the next step? Check if the tree is in min heap or not. Now, this node is already deleted. We no longer have to see it. Okay. Now, check, is this in min heap? Is this binary tree, is this heap tree in min heap form? See, 10 is our parent node. Now, 10, its child node, its children node are 4 and 13. 4 is already, first compare the left child. Is the left child smaller, greater than the parent node or not? No. This is not in min heap form, because what does min heap property says? It says that the parent node should always be smaller than the child node. Okay. Okay, let me tell you one more step before this. What we will do whenever the node is deleted, first check the left and right child. The left child is 4. right child is 13, whichever has minimum value, compare that node with the parent node. Okay, and then if the value is greater than or smaller than in case of max heap or min heap, then do the swapping, perform swapping in that case. Now we already compared 4 with 10. Okay, now since 4 is smaller than 10, we will swap it with its parent node. Now 10 will come down here, 4 will be here. Okay, now check again. Is it in min heap form or not? Yes, it is in min heap. This method is also called heapify method. Okay. Now do the same thing in the array. This was the second step of while you are using the heap tree. Now perform the same operation in array. Now how you will perform the same operation in array? I will tell you that. See, this is our first element, second element, third element, fourth element, fifth element. We already replaced it with the front node or the root node. So we are already considering this node as deleted, right? We will no longer count the array size. We will decrease the array size from n to n minus 1. See? Now what you will do? You will find out its left child and its right child. This is my parent node. Now where will its left child be? Left child will be at 2 into 1 location, which is 4, and its right child will be at 2 into 1 plus 1 location, which is 3, right? So these are its left and right child. Now compare between these two, which has smaller value. Since 4 is smaller than 13, what we will do? We will perform swapping here. Swap these two values, okay? Just a second. Let me rephrase my sentence. I just told you that 4 is the left child of 10 and 13 is the right child of 10. Now which has smaller value? 4 has, obviously 4 is smaller than 13. Now what you will do? You will compare it with its parent node. And since in this case the parent node is 10, so what you will do? You will swap it with the parent, because we have to build this heap in min heap form. Okay, so swap the parent node with its left child. Why are we doing this? We are doing this because we need the heap tree in min heap form. Okay, so after swapping, what will our array look like? It will look like this. Correct? Now let's proceed with 98. 98 does not have any left or right children. So we will stop right now. Stop here only. Okay. Now the third step. We have to delete the node again. How we will perform deletion? We will delete the parent node or root node. Which is my root node? 4 is my root node. Okay. So we will do deletion by swapping these two values. Swapping the root node with its leaf node. Leaf node here is 98. So let me swap these values. Now 98 will be placed here and 4 will be placed here. Okay. Now consider this node deleted. In tree you have completed this part. Now the tree is this one. What will be our next step? Our next step will be to check if it is in min heap or not. How you will check this? This is my parent node 98. 10 is its left child, 13 is its right child. Which has smaller value? 10 is smaller value. Compare it with its parent. Is 10 smaller than 98? Yes, but that cannot be true if you are building a min heap. So what you will do? You will perform swapping here. You will swap these two values. Now the tree will look like this. Okay. Now is it in min heap? Yes, it is in min heap. Now we will perform the same step in this array. How we will do this? Okay, one thing more, you must be wondering, why am I swapping these values? Why just not like delete them? We are storing these values. Why are we storing these values? We are storing this value because you already know that whenever a deletion in an array takes place, the value does not get like randomly disappear. It does not get disappeared, it just gets rewritten, right? You should be aware of this fact that whenever we delete any value in an array, the value gets rewritten. It does not get like it does not happen like if I'm deleting 3 and it will get erased from here. No, it won't. This won't happen. It will still be there, right? And this is already the drawback of an array. So that is why what I'm doing, I'm making use of the storage. Okay. Now let's continue. Let's get back to this array. How you will perform deletion? Now see, this is the first node of this array 4. What you will do? You will again swap it with the last element of the array. I hope the coding will be really easy when you do in this. Okay. You just have to understand the concept. Now 98 will be replaced here and 4 will be replaced here, and now our array size will be n minus 1, which is 3 right now. Okay. Now what you will do? Check if it's left and right children. 98 is my parent node, its left child is 10. I already told you how is it 10, and its right child is 13. Okay. Now which is smaller out of 10 and 13? 10 is already smaller, obviously. Now 10 is smaller than 13. Now compare it with its parent node. Which is smaller, 10 or 98? 10 is smaller. What we will do? We will perform swapping of these two values. Okay. Now just a second. Let me rewrite these. This was, I'm sorry. See, so what we will do, we will swap 10 and 98. Okay. Now my 10 will be replaced by this 98. Now the array represents that the left child is 98 and the right child is 13. I hope that's clear now. Now my array is this much, 1, 2, 3. It has only 3 elements. Okay. See, now what you will do for deletion? You will again perform deletion from the root node. How you will do that? You will replace the root node with its leaf node. This is my root node and this is my leaf node, right? So let's perform swapping here again. Now 10 will be replaced by here and 13 will be here. Okay. Now consider this node deleted. Now the same thing we will perform here. We will swap. Okay, we will do it in the array form later on. This node is deleted. This is my final tree, 13 and 98, right? Now check, is it in min heap form? Yes, it is already in min heap form because 13 is the parent node and its value is smaller than its child node, left child. Now let's come back to array. We will do swapping here also. $13 will be replaced here and 10 will be here and the array size will be 1, 2. Okay. Now yes, this is the left child of 13 and it can be greater than the parent node because it is in min heap. It is already in min heap, right? So now what you will do in deletion form, you will just simply replace it with its leaf node, and leaf node is only 198. So 13 will be replaced here. And this will be considered deleted. Now my final tree will look like somewhat like this with one node in it. Okay, this is my final heap tree. Now continue the same operation in the array form. Swap these values. This is the leaf node. Now this 98 will be put here and 13 will be put here. Deletion of this node will be proceeded by like this is the last node, you can simply delete it. And you will notice one thing in this array. These are the deleted nodes. Okay. And in these deleted nodes, you will notice that the value, this is the 98, 13, 10, 4, 3. This is the sorted array, right? And these are arranged in a descending form. So whenever you require to sort the array, sort the elements in descending form, you will use min heap operation, and this is called as heap sorting. I hope that's clear. Okay. Now let's consider another example by means of this. See, these are the workings of heap sort algorithm, and the PPT will be provided to you in the links. You can download it from there whenever you require it. This is another example you can see, and you can try it for yourself whenever you require. And it's a very simple example. I hope it's very clear how to build a max heap. You can use it. In this example, I'm using max heap to do the heap sorting. And I have already explained you how you can use min heap to do the heap sorting. See, so if for any kind of queries, you can revert back to me in the comment section. And thank you so much. That will be all for today.